Hey guys, welcome back. This is George, and this is part 3 of controlling your 3D curves in Houdini. We're going to be building on what we learned from part 1 and part 2 to break down how I crafted this final render. Alright, let's dive in. Alright, so we're going to keep moving and get into creating groups and shapes with the wire. So we'll grab the line and go into points, and we'll select this here, shift select this one here, create group. And now we got 49 and 0 as a group, and that would be our start end. So if we were to blast these two and delete non-selected right here, boom, now we got those 2 points. The problem is when we select things manually like this, what happens is that if we change the point count, all this ends up messing up. Like, we're still selecting 2 points because we only have 2 points, but look at our original curve, you see? So if the point count changes, then it messes up everything. So we don't want to do it in this format. So we want another smart way to do it. And what we can do is do it with Vex Wrangle, groups by select start and end. We're going to do an if statement. So to do this, we're going to just put if, and we'll put at ptnum is equal to 0, and let's close this. Then we can put open and close bracket, and then put at group underscore start is equal to 1. All right, so we have point 1 is the group and everything else is out of the group. Perfect. So then the next one we're going to do is if at ptnum is equal to the total number of points, so npt minus 1. So if ptnum is equal to the total number of points, we're getting the highest number of points. Minus 1, it'll select the last one. So then we go in here, we'll do the same thing, open and close, and we'll put at group end is equal to 1. And now we have our last one, group end is to 1. So if we were to lower the count and select the group, we could see point 5 is grouped, and 0 is always going to be 1 for the start. So the tricky part was that the last one, but now we have it. So if the number of points is equal to the total number of points, meaning the highest number, and then minus 1, we're actually selecting the very last number, and then we're throwing that into a group, and that is equal to 1. So true, and that's how we get our group. So that's one way to do it. The other way, if you have the qlib library, you could put a group expression, connect that here. And then what we can do in here is in the drop down, there's a start and end point. So we could put start and end. Let's see if it works. So you have to create 2 of them. So you have to create start and then name this start, and then name this end, delete this and put end, and make sure that these 2 are points. And now we have the same thing here. So group start is 1, and then the group end. So those are the 2 different ways of grouping them. And the reason why we're selecting the 2 ends is because we're going to copy our geometry onto the ends of the points to create that kind of effect that something's connected to the 2 ends. All right. So the next thing we're going to do is create a copy 2 points. Okay, and we're going to connect our groups. Let's just put them with a lowercase so they're both the same. And then we're going to copy a sphere. Right now it's copying the whole thing. We're going to select on the target points. We're going to put end, start, and there we have it. We have the 2 pieces of geometry, and then we're going to merge this original line here to this one here. And now we have that connection. Cool. So let's merge this to, not merge this to a null, or let's alt click and then I can connect this one here. All right. And then I'll put a switch and let's do a draw curve. Let's put switch here on the draw curve. We're going to go projection, ZX plane. And then now we can draw our curve, and you can see how that's happening there. And then another thing we can do is just smooth out our curve. 1 and 50 is fine. Perfect. So now if you think about it, we can grab some other things we did here. So we can grab one of the coils maybe. And we don't have tangent U and curve U, so let's just grab some here. So I'll get curve U from here, and then I'll get tangent U. Grab these 2 points, 2 nodes, I mean, and then put them here. And now we have the coil effect happening for us. And then we can smooth this out. Let's add in the resample. Did we do a resample? Let's resample. 0.001. So if we're resampling, we don't need to add these two. Let's just remove those, because what we're going to do is grab it from tangent U and right here. Perfect. And then we're going to do a smooth as well. So we're going to resample after here. And then, yep. So that's good. So we have our kind of janky curve. You could see what happens when you draw it. We smoothed it out, kind of evens out the points, and then we resample it just to kind of add more points in between. We did our coil, and then we smoothed it out, and we merge everything in. Perfect. So now if we were to draw another curve, different curve, we can just clear out the history here and redraw our stroke. But now you could see that it follows, and it's pretty quick the way this works. If we start adding like thickness and stuff like that into the curve, it's going to take a little bit longer to recalculate. But for now, you can just use this and then maybe create a switch that switches in between the geometry and then the non-geometry. So we can go in here and put a switch. And it's going to have the optimized. And then the next one, so we want to add thickness to this. And what I'll do is connect this here to this one, and then do a merge. I'm going to do another merge here. Connect the point here, the copies, the 2 ends. And then in here, I'm going to put a poly wire. And then when we do the switch, we're going to see our poly wire. This is way too big right now, so let's go primitives 0.01. So this is happening here. Just press D, go into camera, and then put 0.001. And now we can get closer without having the camera clip. Pretty cool, right? So we have the thickness here, and then we have the 2 ends. So this is pretty much the building blocks for the cable. We can add a little bit more. So let's add a null here just to kind of separate it, create a straight line. And then we're going to get our displace or our lift. We can get maybe this one and then drop it in here. And instead of doing Z, we're going to change it to Y. And then we'll put plus equals. That way it grabs the current curve and doesn't squish it, because if we don't, it's just gonna squish the entire setup. So we got this here. So if we look at it from the side, we can see that we're lifting up the curve at the very beginning. You can do something like this. the ends stay on the floor and then these stay up, and then we'll just lower it here. Interesting. So something like that would work. So all we got to do now is create like a switch node here where we can grab our file from somewhere. Let's see, HDMI, and then we're going to do a couple of things. So we're going to transform this. So we're going to do 90. Nope. So you can see here that this is being copied and it's going to be exactly like facing a certain way. And what we want to do is grab the actual curvature of the curve where it's created and angle that. So in here, remember I told you that I use polyframe for it. So what we can do is get polyframe and then drop it in here on our curve and then reverse the normal. So N, and now you can see that that flipped. So there you go. So now when we create the curve, let's switch to the optimized curve. Let's redraw this curve here, clear it out. You can see that it's starting to face kind of where we're telling it to go. Boom. And then the coils, we can just not have coils like at the very start. There you go. So you got your coil, you got the displacement for the coil in there. And then if you wanted to do the wired one, you could do that. So the only thing that we're missing here now is, oh, let's add some divisions on here. Looks pretty bad. So what if we wanted to drive the thickness of this wire? And so what we got to do here is calculate the thickness first. So we'll get attribute wrangle, call this thickness. We're going to create an attribute called thickness. You can name it whatever you want. You can put width or whatever. And we want to drive it with a channel ramp. And we're going to type in thickness. And we're going to use curve view to remap this curve in there. And we want some control over the thickness overall. It's going to be a channel float. And we'll name this amount. Perfect. And then we'll multiply this by 0.01. Otherwise, it's going to be really high and make our curve really thick. All right. And then, so now that we have thickness, we need to plug in this attribute into the poly wire. And where it says radius, we could paste that in there. So now we can see how this works. So in here, I could lower the thickness, and then this drives the scale. So you can see it gets really, really thin or really, really thick, depending on how we set up the wire. And then you have your curve set up there for the wire. Now, the next part about all this is bringing this into Solaris and making sure that we can add textures and stuff. So normally this one doesn't really come with a good enough UVs for it. So there's, if you install labs, poly wire labs, and this one, let me turn this off before it crashes. So I have this to 1, right? But we can do it with attribute, and we'll put width. Perfect. So we got, so for polywire is a little bit different. We got to add the width attribute here. And that's how we add it in here. So in here, it's a little different. We just put it on the wire radius. And in this case, it gives us the option to do width attribute. So I renamed this from thickness to width. So, and we could just remove what I did here. So if we do thickness, so just so you know, you don't have to do width, the name. So you just put thickness, and then that's what that does. And then this is the multiplier. It makes sense. I think that's a good way to do it. And then we have the proper UVs, as you can see here. And then we'll add some subdivisions, and we're pretty much good with the cable. So what we're going to want to do is on the copy to points, we're going to add all of our different pieces of geometry. So all of our switches and things like that. So what we did is we grouped the ends and added shape to the curve. All right, let's save this out. All right, so we covered a lot so far. We've covered curve U, tangent U, how to create the coils, how to group them and shape the curve. And now we're going to see how everything is implemented in here. And so we have the draw the wire. So I drew the curve. Then I have my modify section where I do all the different coils and things like that. And then here we have the wire thickness and then UVs and different things there. And then in here we have our different models. So in here we have all the different shapes, right? So we got two switches for the two ends. Right now this one is linked to the first switch. So anything I change, it changes to the other one. And then we are grouping the ends here. We're copying to points, the two ends there, this one, and this one. And then we're merging everything in. And now we have our cable with the coiling, with the proper lift there. There's another thing that I did that you don't really need to do, and it's to like kind of squish it just a little bit, is I added here a mops fall off. I put mask and then here. So what I did with the curve is I squished it. Then I used the mops fall off to create a gradient from between the formed shape. And then I'm using a blend shape right here to go in between those two. And in the blend shape inside of the blend mask, I just put mask. You could put mops fall off, whatever it comes with. And you could see, so if I change this, there's different effect for the squish. Okay, so that's kind of the only difference there in that setup. And then if we go inside real quick, I'm going to show you plasticity. So if we go inside plasticity, we can see these are all the models that I created. Each one of these, I added a different color to it. The colors don't come in correctly. They come in as like a number code. So what I ended up doing is naming each piece of geometry the color that I wanted. So black, gold, and so on for all of them. So when they come into Houdini and you feed them through Solaris, so if we take a look at Solaris real quick, when they come in here, they come in as the full shape. So we don't need the actual groups anymore. So what we can just do is drag the entire shape. And because it's on the root and it's already linked to a color, when we start switching our inputs for our different curves, the colors will automatically assign to the new pieces of geometry just because they're already on the root with the same name. So in here, inside of the material library and the assign, we have, you see the / black. So anything that comes in through that switch, it's going to detect the piece of geometry and it's black. It's going to assign to it automatically. So what you want to do is make sure you have all the proper materials that you want to create for it and place them inside the material library and then assign them to all the different some materials assigned to the same materials. All right, and then that's pretty much it. This is just some simple lighting. I did a dome light. I deleted it because I was having some errors with it. But what I did here is a node that's kind of like a skybox HDR, like just fake, not really anything. And then we'll put OP and then paste this in here. Let's save this out. And so if we take a look at our render, let's get our camera in there, and our dome light is not bright enough yet. So yeah, and then for the changing of the focal length, we can just select the camera and then type in Shift F and then Shift click, and then we can get our focused point there, and then just click on this to get out. And right now it's not really working, so let's pin this and let's go into it's not working. What I mean is it's not correctly, these lines are not correctly set up. I had it for the HDMI. So HDMI is, don't know what that is. So it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 minus 1 because it's 0 is that. So we'll do 11. Let's go back into Solaris. Let's bring in our object. And we have here camera. Let's go inside camera 2. And let's see. Plugs. Got dome light. And then stage. Perfect. So let's save this out. And then now we can see if we render it out what the final product was. There you go. And that's pretty much it. So the emission, we have a mix node and we have 2 unified noises, some with more detail and then another one with the offset. And then in here we have another noise that mixes all of that together. And then it's on emission and then we just have color. We chose that color there. And then for the floor, same thing. It's just all displacement. And we have a unified noise here. We have a frequency of 500. This one is a frequency of so it's 1,000 and we're multiplying it by 2, so like I guess it's 2,000. And then here we have unified noise that's fractal. It's not like that kind of cell shaped like little squares, and that is breaking it up into like a fractal pattern. And then in cable, we just have a little bit of displacement. We created displacement in cops, and then we did another one in cops here. And what we just did for that was created a tile. So here's the tile, and it's this kind of basket weave right here. We added the number of rows and all that stuff, and we added a little bit of gradient right on that. And then we didn't need any of this, so I could just delete that. And then we blended, so instead of using the black and white, we used it as a mask to blend in between these two colors. And then we put it on an out null. And then this one is for displacement. I blurred it out because with displacement, it just goes kind of jaggedy straight up. So I blurred it and I used that. And then you already saw this one was for the dome light. That's what we added. So if you are thinking of this setup, like you don't want to have this crazy amount of nodes if you're going to be creating multiple setups of different things. So what you can essentially do eventually is create a digital asset. So if we go into right here, wave effect, right? So we have this and we're like, oh, well, I want to create a digital asset. So what you do is grab all this, create a subnet, and then, box it in like that icon, and then create digital asset. And then you're going to create all the different attributes you want to tweak on the outside, and you'll be pretty much good to go. So I created one a while back. It's different. It's not the same, but it has all the different effects that we kind of talked about. So this one has like a coil. So let's change the background to light. So this one has like a coil, right? This is the coil segment, amplitude of the coil. We're, spreading the coil. You already know how to do all that. And then what we have here is like plugs. Yeah, right now I didn't have anything set up, but I wanted to eventually put that. So this is just a template. And then if we just play the curve, then we have that effect going through the whole thing. And then the other great thing about having it in an HDA is that if I have draw a curve, put the projection plane to ZX, and we'll start drawing our curves. And we wanted to grab all these curves and do the same effect. So we'll do a for each connected piece, and then we'll throw this right in the middle. And now I have all the cables for that. Yeah, granted, they're all the same, but if you're doing something for the background, it kind of adds more variation. And then you could just kind of duplicate that setup and do a little bit more different things with it. We covered a lot in the last few videos, and just wanted to congratulate you for getting this far. And these files are going to be available on Gumroad, so check them out whenever you get a chance, and I'll see you guys on the next video.